Hello everyone, once again to this new lecture, lecture 5, that is 2 wattmeter method. It is one of the special method for measurement of 3-phase power method. As we suggested, as wattmeter have a 2 terminals, current coil and pressure coils. As connected in one of the diagram, I will show you. It is a main, line and common connected for measurement of power. Now as we connected for single phase power measurement, the current can be measured for line voltage, and voltage measured by pressure coil should be your line voltage should be there. So main, line, common and voltage should be there, as well as significant in previous field also, where cos phi, when we measure the power, the cos phi basically angle between the pressure coil and your current coil. Now when we're talking about 3-phase wattmeter, for 3-phase power measurement, we have one of the method that is called Blondel's theorem. It will suggest that if you have uh, n phase of power measurement, if we wanted to measure the n phase of power measurement, you can use only n minus 1 wattmeter to measure that particular power. So for 3-phase of power measurement, you can only use 2 wattmeters to measure the 3-phase of the power measurement. In this particular method, we introduce one of the method where we use 2 wattmeters to measurement the 3-phase of the power. Here we include that these 2 wattmeter are been connected significantly, such that one of the wattmeter one W1 we suggested it will connected such that A phase, the current coil carry the current of IA, where the wattmeter 2 carry the current of current coil IC current, where the potential coil of wattmeter 1 measure the voltage between VAB, measure the voltage VAB, where the second wattmeter measure the voltage VCB. So as we say, the both the wattmeter having the common voltage or common node at the particularly phase B. Okay. Now this particular condition where the both the wattmeter carrying the different current, but they having the common node phase, that is called B phase. The both the potential coil can be connected with respect to their phase, like VAB and VBC. Now if we wanted to note the readings, where we assume that the where we also noted if it is a we have to be measure the power in star type of star type connection of 3-phase power, then it is a your line voltage, it is your phase voltage V phase, and it is VAB is your V line voltage, where VA is your line voltage, and what should be the current going to a load, it is called phase voltage. In case of your star connection, phase and line current should be equal, that is we can indicate it as I, where V phase, in case of star connection, V phase we calculate as V, indicated as V, then V line voltage, as we know in previous formulas also, V line voltage is equal to √3 of V. Here we assume that whatever the V connected load, it should be having the lagging power factor. Now calculate the power measurement due to the both the wattmeter W1 W2, then it could be from the wattmeter A VAB, current IA, and phase angle between them VAB and IA. Now we have to measure the power in secondary wattmeter, that is VCB multiplied by IC, VC multiplied by IC, and angle between the voltage VCB and IB also, and angle between them. Now power 1 and power 2, here we will indicate that, here we strongly indicate that total power which is P1 plus P2 to the wattmeter 1 and wattmeter 2, it will show the 3-phase power measurement. What is mean by 3-phase power measurement? It is √3 of VI cos phi. It will indicate √3 of VI cos phi. We have to be we verifying that total power due to what the wattmeter give the this particular formula or empiric formula, it is root through vi cos phi for a three-phase power. Let's verify this. As we know, the VCB, it is your basically it is a line voltage, so it acts as a 3V root 3 of V, put here and put here also root 3V, and IA and IC are the line currents, so I and I. Now only thing that should be considered left should be the angle between VAB and IB and angle between VCB and IC. Now we have to be calculate this by using the phasor diagram. What phasor diagram suggested? Phasor diagram suggested we have a three-phase voltages. We will first assume that the three phase voltages VAN, VBN and VCN are in 120 degree out of phase with each other. Now if we wanted some voltage VAB, VAB is what? VAB is equal to VAN plus VNB, or we can say it is minus of VBN. Okay, you can say both, VAN minus VBN, okay, or VAN plus VNB, whatever you can say. So we have to be calculate, we have to wanted VAB, that is your line voltage. So first put VBN in the opposite direction, 180 direction, to getting minus of VBN. For this particular formula, VAB equal to VAN minus VBN. So minus VBN and we have VN. So getting the resultant, it is VAB. Getting the resultant VAB. So more important thing, if I say the voltage difference between them is 120 degree, whatever the angle between them, it is 120 degree. If VAB is in phase opposition in between them, then there should be voltage between them is 60 degree. It is cut them in two halves, it is 60 degree. And if we wanted a line voltage VAB, it is with respect to VAN is what? 30 degree, is again half, it is 30 degree. Now 120 degree first between VAN and VCN. Now VBN what? 60 degree and it is 30 degree now. So voltage between VAN and VAB is 30 degree. As we assumed in previous slide that this particularly load is lagging power factor. What is mean by lagging power factor? Our phase voltage is lead the current IA by some angle phi. This angle phi, we will calculate this. What is the now angle between VA and VAB? We have to calculate. It should be 30 plus 5. So we will calculate 30 plus 5. Now secondly, we have to be consider the voltage VCB. How should we VCB? So first we have VCN. We have VCN. Now we also getting minus of VBN. So having the resultant of VCB. We having the result of VCB. So what is the voltage? As we know, this IC current is lagging behind the VCN by some angle phi. Now what should be the angle between IC and VCB? That is a 30 degree angle between line voltage and this particular phase voltage. So 30 degree minus 5, that is your angle. Now put both the angle in our previous formula, that should be root 3 VI. For first wattmeter, it is root 3 VI cos 30 plus 5, root 3 VI cos 30 minus 5. Now add both this formula, you will get 3 of VI cos 5. That is our formula from 3 phase wattmeter. It is 3 V phase I phase cos 5. That we also getting from previous formula also. In previous 3 phase wattmeter, what we wanting. So hence prove that 2 wattmeter method is actually you can be made getting the 3 phase power measurement. So what are the special cases for this? Some of the special cases and treatment are like this. If commonly one more thing are to be getting in this, that if we use this power factor, it is unity, or when phase is equal to 0, then power factor both the wattmeter read the equal value. if if the load is smaller, or if we say if power factor is uh, half, then phi is 60 degree, then the one wattmeter read the zero reading and other have some positive value. If we decrease the power factor after that also, then one of the wattmeter read the negative value. So it one of the case, it is a very important case where we suggested that if the power factor is smaller than if greater than 60 degree, between 60 degree to 90 degree of angle, or between zero power factor to half power factor, the one of the wattmeter read the negative reading. It is one of the important in one of the classical your aptitude exams, the technical aptitude, they will talking about and putting the question after it also. How it will getting the decision taken by reversing the connection of current pressure coil, and it can be connected as a reverse current coil. It can be corrected in that manner. So now as we calculate, the true power or active power in this particular manner. Now by using the 2 wattmeter method, we can also calculate the reactive power in the system. How will calculate? First we will in previous method we will add both the values. Now we are subtracting P1 minus P2. As we subtracting P1 minus P2, we will getting the answer of root 3 VI cos phi. So what we wanted? We wanted only 3 VI cos phi. What we wanted necessarily to be VI sin phi. But what we getting? We getting root 3 VI. So we have to multiply some value of root 3. So getting 3 of VI sin phi. So we have formula. If we multiply root 3 by subtracting P1 and P2, we will getting the reactive power system. So in manner, so we wanted to calculate the power factor of the system using P1 and P2 value. It should be necessary we can getting the power factor also by this particular formula where we say root 3 P1 minus P2 P1 plus P2. So start with some of the numerical fundamental for this 2 wattmeter method. Is one of the university's question, where we suggested that if we have 3-phase power having the line voltage of 115.5 ampere and power measured by 2 wattmeter, one is 40 and another is 0. What is this condition? In this condition is where we using the power factor as 60 degree. Okay, as as a power factor having the 60 degree, first they wanted what should be the power factor. If power factor is unity, then line current is same and what will be the reading of each wattmeter. So in this particular case, they will say that we have to calculate total power, that is P1 plus P2. Total power is 40 degree. Now as we know the power is 40 degree and we know the your line voltage and line current, we can calculate the power factor to be 0.5, that is phase angle to be 60 degree. Okay, now first part is completed. Now in second part, if power factor is unity, in case power factor is unity, power factor is 1, then total power can be calculated, can be replacing only cos phi value, then overall power to be 80 watt. So the total power is increased by 80 watt. It is one of the important thing. Then so reading will be, then what will be the reading of individually? What will be reading of P1 and what will be reading of P2? If phi is equal to 0, then if we replace phi is equal to 0 and phi is equal to 0 and we know VL and IL, then total power should be 40 watt and 40 watt. They will provide it a equal and opposite values. So thank you all of you. So for this particular part, we'll be using 2 wattmeter method for measurement of 3-phase power.